There are many different ways and methods in which we can use to solve linear systems. These include substitution, elimination, and matrices. Given this set of linear systems, what would you do to solve it? Let's start by using the method of substitution. Since we are looking for the value of x and the value of y, we need to start by making one of these values the subject of the equation. Let's start by making x the subject of this equation. Let's rewrite the first equation here. X plus 2y equals 24. We subtract 2y from each side of the equation. X equals 24, take away 2y. Now we have x as the subject. We take this newly formed equation and we substitute it into the second equation. Therefore, here, instead of writing x, we actually write 24 take away 2y. Let's go ahead and do that. 24 take away 2y, take away 5y equals 23. We now combine like terms. Negative 2y plus negative 5y equals negative 7y. Therefore, 24 take away 7y equals 23. Now we solve for y. We subtract 24 from each side of the equation. Negative 7y equals 23. Take away 24. And now we divide each side of the equation by negative 7. Y equals 23. Take away 24 divided by negative 7. Here we are also making y the subject of the equation in order to solve for it. Plugging that into the calculator, we get 23 take away 24 over negative 7. That is 1 over 7. This is the value of y. Now we take the value of y and we substitute it onto the first ever equation, this one. Let's do that. X plus 2 multiplied by 1 over 7, that is the value of y that we found out, equals 24. And now we solve for x. X plus 2 multiplied by 1 over 7, which is 2 over 7, equals 24. Now we subtract 2 over 7 from each side of the equation. X equals 24, take away 2 over 7, and now we solve for x. 24 take away 2 over 7, that is 166 over 7, which is approximately 23.7. There is another way we can solve linear equations, which is called Cramer's rule. This method uses matrices to solve linear equations. Let's start developing the first matrix, and that is D. The first matrix consists of these values: 15, negative 3, 2, and 5. So therefore, 15, negative 3, 2, and 5. This is the first matrix that we develop. The second matrix is called dx, and it consists of these values: 80, negative 3, 10, and 5. And finally, the third matrix is called dy, and it is a matrix that consists of these values: 15, 80, 2, and 10. Now let's go ahead and solve for x and y. Starting with this matrix, let's find the determinant. We know how to solve for the determinant by multiplying 15 by 5, take away 2 multiplied by -3. Therefore, 15 multiplied by 5, take away 2 multiplied by -3. 15 multiplied by 5 is 75. Take away 2 multiplied by -3, and that is -6. 75 take away -6 is 81. Let's find now the determinant of this matrix. $80 multiplied by 5 is 400. 10 multiplied by -3 is -30. 400 take away -30 is 430. Finally, let's find the determinant of this matrix. $15 multiplied by 10 is 150. 2 multiplied by 80 is 160. I prefer to add brackets to make sure not to mix up the signs. 150 take away 160 is -10. We have found these three values, which will help us find the value of x and y. In order to find x, we take dx and divide it by d. And in order to find y, we take dy divided by d. All right, dx is 430 divided by d, which is 81. This fraction cannot be simplified any longer, therefore this is the value of x. Now let's solve for y. dy, which is -10, divided by 81. This fraction can also not be simplified any longer, therefore this is the value of y. We have therefore used Cramer's rule to solve for x and y. Now, in order to make sure that our answers are correct, we simply substitute x and y into the equations, and we see whether they equal these numbers. Let's substitute the value of x and y into the equations. 15 multiplied by 430 over 81. Take away 3 multiplied by -10 over 81. If we plug this onto the calculator, it must equal 80. If it doesn't, that means we did not solve correctly. It does equal 80, meaning the value of x and y are correct. This is how we can be certain on the exam or the test that we actually solved for the correct value, is to make sure that these values of x and y really do equal the values that we have here in the equation. Given this set of linear equations, solve for x and y. Now we notice that the set of equations is not in the correct order. The values of x and y are not in the same column. Here we must have the values of x, and here in this column we must have the values of y. Therefore, we need to readjust this set of linear equations in order to solve. It will look like this. Now we can actually go ahead and solve for x and y. We don't need this anymore. The first matrix is D, and it consists of these values: 5, 3, 10, and -5. The second matrix, Dx, consists of these values: 17, 3, 10, and -5. 17, 3, 10, and -5. And finally, the last matrix, dy, consists of these values: 5, 17, 10, and 10. Let's find the determinant of each matrix. 5 multiplied by -5 is -25. 10 multiplied by 3 is 30. -25 take away 30 is -55. 17 multiplied by -5 is -85. 10 multiplied by 3 is 30. -85 take away 30 is -115. 5 multiplied by 10 is 50. 10 multiplied by 17 is 170. 50 take away 170 is -120. Now we solve for x and y. X equals dx over d. dx, -115, over d, which is -55, is simplified to 23 over 11. Y equals dy over d equals -120 over d, which is -55, and that is simplified to 24 over 11. We have therefore solved for x and y, and we can verify our answer by substituting these values into the set of linear equations to make sure that we actually got the correct answer. Let's look at another way we can solve linear equations. The method that we're going to use this time is called the inverse coefficient matrix. We basically develop two matrices from the linear equations. We multiply them by each other, and then we solve for the values of x and y. Let's start by developing the first matrix. Now, the first matrix consists of these values: 15, -3, 2, and 5. As we've already learned from the previous video of matrices, in order to find the inverse of a matrix, we first have to find the determinant of the matrix. Finding the determinant is taking 15 multiplied by 5, take away 2 multiplied by -3. 15 multiplied by 5 is 75. 2 multiplied by -3 is -6. 75 take away -6 is 81. Now that we've found the determinant, we have to flip this matrix into the inverse coefficient form. And that is D negative B, negative C, and A. In this case, 15 is A, negative 3 is B, 2 is C, and 5 is D. We take these values and we flip them in this order, which is simple. Therefore, the matrix becomes D is 5, negative B is negative 3, so negative, negative 3. Negative C is 2, it becomes a negative 2. A is 15, and it goes in here. We have developed our 2 by 2 inverse coefficient matrix. Now, before we develop the second matrix that we need, we have to take 1 over 81, which is the determinant of the matrix, and multiply it by this matrix. Let's go ahead and do that. One over 81. We notice here that we have two negatives, which will become a positive. Therefore, this is just positive 3. Right, now we go ahead and multiply. 1 over 81 multiplied by 5 is 5 over 81. One over 81 multiplied by 3 is 1 over 27. 1 over 81 multiplied by negative 2 is negative 2 over 81. 1 over 81 multiplied by 15 is 5 over 27. Now that we have developed the matrix that we need, let's develop our second matrix. The second matrix is a 2 by 1 matrix, and it consists of these two values, 80 and 10. Now, given these two matrices, is it possible to multiply them? Let's check. The number of columns of the first matrix is equal to the number of rows to the second matrix. This means that yes, we can multiply the two matrices, and we are aware that the resulting matrix will be a 2 by 1 matrix. So let's go ahead and multiply these two matrices. As we know, we must always go row by column. So first, we take this row and we multiply it by this column. Then, we take this row and we multiply it by this column. Let's start by multiplying this row with the column. 5 over 81 multiplied by 80 is 400 over 81. 1 over 27 multiplied by 10 is 10 over 27. Now we add those two values and we get 430 over 81. Now we multiply this row by this column. All right, negative 2 over 81 multiplied by 80 is negative 160 over 80. 5 over 27 multiplied by 10 is 50 over 27. Adding these values together yields negative 10 over 81. Therefore, the resulting 2 by 1 matrix is this: 430 over 81 and negative 10 over 81. This is the value of x, and this is the value of y. If you recall previously on this video, that these are the values of x and y that we have found by using another method to solve the linear equations. Therefore, we have solved for x and y. How about the method of elimination? In this method, we eliminate either x or y. We find the solution for one of the values, and then we use substitution to find the other value. Let's say we will eliminate y. Here we have negative 3y and 5y. We need to make them the same number but opposite signs so that we can eliminate them. Now the least common multiple between negative 3 and 5 is 15, which is obviously 3 multiplied by 5. Therefore, since they are already the opposite signs, all we have to do is to multiply them by each other. Meaning, we multiply the top equation by 5 and the bottom equation by 3. This will yield 15x multiplied by 5 is 75x. Negative 3y multiplied by 5 is negative 15y. 80 multiplied by 5 is 400. 2x multiplied by 3 is 6x. 5y multiplied by 3 is 15y. 10 multiplied by 3 is 30. Now, in order to eliminate y, we must add the first equation with the second equation. 75x plus 6x is 81x. Negative 15y plus 15y cancel each other out. 400 plus 30 is 430. Now we can actually go ahead and solve for the value of x. Dividing both sides of the equation by 81. 81 divided by 81 is 1. X equals 430 over 81. We have found the value of x, and now it is very simple to find the value of y. We will use the method of substitution to find the value of y. Now, we can substitute the value of x in any of the 4 equations that we have. We can substitute the value of x here, or here, or here, or here. Either way, we will get the same value of y. Let's go ahead and substitute the value of x in this equation. 2 multiplied by x, which is 430, divided by 81, plus 5y equals 10. Now 2 multiplied by 430 over 81 is 860 over 81 plus 5y equals 10. Now we can subtract both sides of the equation by 860 divided by 81, and that would be 5y equals 10 take away 860 over 81. Dividing both sides of the equation by 5 yields y equals 10 take away 860 over 81, all divided by 5, is negative 10 over 81. That is the value of y and x.